Okay, welcome everyone to today's University of Texas Energy Symposium. I'm Carey King. I'm a research scientist and assistant director at the University of Texas Energy Institute that sponsors the Energy Symposium. Today we have Raiford Smith with Google, and before I introduce him more formally, I would just like to point out the upcoming talks. So next week we will have Eric Danziger, who is managing director of their effort called the Energy Transition for Investing. It's part of Riverbend Energy Group in Houston, and he's going to talk to us about their efforts in investing in companies associated with energy transition. And then after that, November 2nd, we have the president and CEO of the Electric Power Supply Association. So they're kind of the electric power organization for public utilities. So we're going to hear about his thoughts on how to have a reliable and competitive energy future. So we've got lots of energy and investing and innovation. And today, we perhaps have one of the best people to talk to us about innovation in the energy sector. And this is Raiford Smith. His title of his talk today is The Rise of Analytics and Digital Infrastructure in the Energy Industry. And so Raiford is with Google, and his title now is working in products and technology with the Moonshot factory, but he's involved generally in the cutting edge efforts of Google's efforts in energy, generally speaking. And so he's quite knowledgeable about all efforts there in terms of their decarbonization, their moves to understand the energy system and to make it more adaptable to all our needs, not just Google's, but everyone's. So he's going to talk to us about the 3Ds of decarbonization, digitalization, and distributed resources, and how this is transforming the electric utility industry and the role of Google in this. I met Raiford some years ago when he worked at CPS Energy. Raiford has spent his entire career in the electricity industry, or practically most of his career, I think, in the electricity industry at several different companies, mostly utility companies, and now Google's leading their efforts. So he's taking all of that knowledge and putting it into that so-called tech industry. We know it's tech all across the board, but so now we're going to learn sort of what the cutting edge and what he's thinking in terms of using information to help us have a more reliable and decarbonized electric grid. So he has a tremendous amount of experience. With that said, I'm going to now hand it over to Raiford and stop sharing my screen if we can. And I'll remind everyone to ask questions at any time, and I will try to interject with your question if I can while Raiford is speaking, and answer or put your questions in the question and answer section of Zoom, and I will forward them to him. So with that said, I will now stop speaking and hand it over to Raiford Smith of Google. Raiford, go ahead.
Thanks, sir, and thank you to everyone for participating today. I look forward to the conversation, and feel free to add questions into the chat, and I will happily go through them. So first, I thought in any sort of discussion about analytics, why don't we start in the very beginning and kind of look back a bit in time and see kind of how we got here. So just a quick history lesson in terms of analytics from the 70s to the mid 90s. Big data was, basically monthly meter reads, and that was, kilobyte sized data, which is very small. Programs were written primarily in COBOL and assembler, and I'm going to date myself, but I've actually programmed in those languages. And then utilities wrote their own software, which seems kind of surprising, but they did for the most part to manage that data. And then data collection was largely manual, as was data cleanup. And utility assets, most of them, they were analog. Only a few digital assets started appearing on the transmission system, and really only starting in the mid 80s. Starting in the mid 90s, though, we had a whole lot of concern around Y2K. And so utilities really began converting in large scale all of their software to enterprise or third-party applications, or frantically writing patches and replacing computers wherever they had them. There was a rise of things like Mosaic, Netscape, and Internet Explorer, and ultimately things like Ethernet, email, and networked resources. So they shifted from mainframes now to these networked computers and email and web browsing and that sort of thing. Data collection was still largely manual, and most of the assets outside of the transmission system were still analog, all the way up even until Y2K. once that we flipped the calendar and started in the 2000s, 2009, as part of the American Recovery and Investment Act, we had the smart grid investments grants, a few $1 billion that got sent out to the utilities. And that really kickstarted utility spending on grid modernization and, of course, the production of a whole lot of data. A couple other notable dates: 2012, they found the Utility Analytics Institute. And in 2015, really almost 2016, the Ukraine grid was shut down remotely by hackers. And then in 2018, by about 2018, we've reached about the halfway point in terms of adoption of just smart meters alone. So that says there's a lot of room to grow. So with that, that kind of brings us up to today. And there are actually, as Carey mentioned in the introduction, there are actually several different things going on simultaneously that are creating issues and opportunities for the electric grid today. The first is the digital and decarbonization transformations. And what that means is that from a decarbonization perspective, really up until even just right now, most of the generating assets that were out there on the grid were fossil-based, nuclear or hydro, but mostly fossil-based. Now what we see is in ever-increasing numbers, we see customers, whether at the retail level or at the large wholesale level like Google, increasingly adopting renewable energy, solar, wind, and then adjacent technologies like battery storage. We also see a lot of electric vehicles, both coming as well as connected and networked today. And then a lot of assets have been converted, and still many more to come. They've shifted from being analog devices, as was mentioned earlier, to now these networked, intelligent digital assets. And that means they're producing an incredible amount of data. So the decarbonization is doing a giant wholesale change on the supply side, but because they're all powered by digital electronics, and customers and utilities are both rapidly adopting digital technologies, we see this massive digitalization wave happening at the exact same time. And while all that's happening and they're producing all that data, the data itself is really a mess. And so there's very little transparency or accuracy in any of the information. Often the network models and the data themselves from different systems are completely siloed. If they're out of date, meaning that what they think of is correct is 15 minutes old or older. And as you know, these sort of distributed energy resources, they change their states within seconds. And so this information is now rapidly out of date. The data is often sparse too. You've got some parts of the grid that are extremely well censored and other parts that don't have near enough censoring. They're also not accurate. I'll never forget at one stop in my career, I was leading efforts on smart grid, and we talked about how we were implementing all these great changes. And I said, well, I'm really glad we've got this metering system that we're putting in place. How much data are we collecting around voltage? And they said, oh, we're not doing any of that because we put in the AMI system to render a bill. And ultimately, what that means is that they had information that they could have collected that would have been really useful to do a lot of other things with, but because they designed the system really just to render a bill, they weren't actually collecting it. So they didn't have the right or accurate information. And it was really difficult to contextualize all that information. Just naturally, with all those silos and all those different areas, whether it's customer data, utility data, or a mix of the two, contextualizing it, creating something useful out of it was really, really, really hard. And while all that's going on, the distributed energy resources themselves are creating enormous pressures on the grid. Grids are traditionally had long time horizons to deal with the changing state of a generator, and they had large control over it. Now they don't. At the same time all that's going on, this transition to carbon-free energy and digitalization of all these assets means that now cybersecurity, privacy are increasingly very, very, very important attributes that largely have not been paid as much attention to in the past because they were obscure, they were difficult to get to, or it wasn't really that high a need. Now, however, as we saw from the Ukraine and various other things, suddenly security and the resiliency of the grid is paramount. And so all this stuff is going on simultaneously. And what it's creating, in addition to kind of just the change management issues, is the need for basically harnessing the data to find out and use for better purposes. So we're going to talk a lot about that today. Often, however, utilities, when they think about this situation, is they're very much worried and concerned. And by the way, being at Google, one has to have a lot of memes, and so I've got quite a few here in the deck. But this is kind of the typical response when people are looking at either way too much data, they don't know what they're looking at, they don't know what to do with it once they've got it. And so what we want to talk about today is how are utilities essentially turning the page, how are companies in the energy space turning the page, and how are they kind of avoiding this sort of situation so that they actually know what they're looking at. So first, a couple of important learnings along the way that I've picked up. The first one is what not to do. And what we always see when there's a new project coming along is that people are really excited about putting in some new technology or sensors, basically to do something new and better for their customers and enhance the system. Unfortunately, what happens is that they often design it with the use cases that it's originally intended for, but they don't think about how the data could be used and repurposed in so many other ways because it's just outside of the scope of what they're doing. So the first lesson learned that utilities are learning in an often painful way is to architect the solutions so that the data, both the stuff that flows into these systems, these new capabilities, and the data that's generated from them, that comes out of them, that they can be repurposed. This allows you to add on analytics and capabilities without having to have an integration nightmare. And so this is the first and most important of the lessons that they learned. And in starting it, this is where typically companies feel like they begin. And the top left, you see kind of the company executives. They're either really out of touch with the technology and behind, or they're really confused by it, or perhaps they're just really enthusiastic about it. One way or the other, that's kind of where the executives start from. They have a feeling, though, that there are lots of people with analytics experience, but unfortunately, moving left to right, most of those people aren't actually at their company. And so this leaves them kind of wondering, okay, well, how am I going to start to develop this? And often they turn to vendors and consultants for their help, but they also view them a bit skeptically, primarily because they think that perhaps they're going to, sell them a bill of goods or not necessarily understand their business. One way or the other, though, they're eyed a bit skeptically. And one of the things I've seen more often than not is that the primary analytics tools within a company is a spreadsheet. And that's because that's something that lots of people have experience with and they can kind of manipulate. But spreadsheets themselves have lots of limitations, especially with the amount of data they can look at and the things you can do with them. And so while that might be a primary analytics tool, it's not really an analytics tool. In the bottom right, something that inevitably they find is that their data quality and data access is just really terrible. And they have to first spend a lot of time trying to actually get that stuff straight. So this is where they start. And then I like to use this analogy as a way to help people understand what analytics really means. Analytics seems like a very esoteric or very technical area that might seem overly complex, or having you have to have some sort of advanced degree in math to be able to understand. But really, analytics is just being to proactively use data to create valuable insights. As I used to joke, it's like the old BASF commercial. Analytics really doesn't do anything new necessarily. It just does everything you do better. And so that's the whole idea here. But what does it really mean when we say analytics? Well, there are four key components. The first one is the strategy and the staff. Basically, the whole idea here is that these folks are around to tell you where to go, what it's worth, how it's going to be prioritized, and when we're going to get the work done. These people you've got to have, and they're the driver in the car. The next piece, excuse me, the next piece is the actual fuel itself, which is to say, this is the data. So if you've got a person who's setting the strategy and basically doing the work, what you've got is the fuel, the data. This is what's actually powering that analytics engine. It needs to be governed. It needs to be engineered, meaning moved around where it needs to be. It needs to be stored. And so this is the second component. Now, the third component itself is once we take that raw energy of fuel, of data, we need to turn it into something else, right? And that's what the engine does. The engine translates that fuel into movement or insights. And these insights are the things that are going to move our car forward. But ultimately, the engine itself isn't necessarily directly hooked to the wheels. And so you've got to have some sort of way to visualize what's going on, because when you're standing outside of the car, you can see the person in the car clearly doing the work and, doing the steering wheel or shifting gears or doing whatever, but you may not be able to actually see what they're doing. And so the last bit is the way to visualize it so that everyone around them can actually see the car. And these are the results. This is how we see the results and how we interact with the results. And so at the end of the day, analytics itself isn't just doing one of these, it's doing all four of these. It's having a strategy and staff, it's having the raw data that you're going to govern and move to the right place and make sure that it's available for use. You're gonna have an engine to actually create the insights, and then you're gonna bring those insights to life in ways that people in doing their jobs, the analytics itself can be visualized with. But when we think about that, a lot of companies think they have to go out and hire a lot of smart people, perhaps from other industries or people without necessarily much energy and experience. And that doesn't necessarily imply they're actually going to do a good job or they're going to get great results. In fact, I would argue that recruiting lots and lots of smart people alone probably is a good way not to do well. Like, you have to have homegrown talent. You have to have people who understand the context of your business, and they have to be familiar with these tools. So you're going to have to grow them. And it's going to take a lot of time, but it's really necessary to building up a good and sustainable capability in analytics that your company can harness for years to come. And with that, there are really 5 different areas that you're going to need within this area, within analytics. The first is the data scientist. Basically, this is someone who's probably pretty good at math, statistics, and creating what are essentially computationally complex models to create the insights. Data governance. These are people who are very familiar with and used to the management of data. That means doing things like defining the quality, the architecture, the semantics, the dictionary, stewardship type functions associated with data. Data engineering is another important one. Basically, their job is to move the data. So while the data governance people are trying to make sure that the quality and capability is there in the data, and the data scientist is trying to transform that data into that insight, the data engineer makes sure the data is in the right place at the right time. The fourth one is business intelligence. These are people who are taking the outputs from those models and they're turning them into dashboards, reports, or otherwise integrating them into the workflow of the process. These people are critical because to create an insight is one thing, but to be able to push it into a workflow where people can interact with it is of critical importance. You can create a model that does awesome things, but if you don't find ways to connect it to the practical work that's going on a day-to-day basis, it's still not very useful. And then last but not least is program management. This is an area that I find a lot of people don't invest enough in, which is, at some point you're going to have to decide what's the priority of these use cases, what's the cost benefit estimates, how much resources should be allocated, and kind of where is work today. So you're going to have those sorts of folks too. But all in all, there are these 5 different categories of people that are working on analytics or should be working on analytics within energy companies and even here at Google today. So let's talk a little bit more about data governance. Data governance is perhaps an arcane art, one that's not well appreciated. I find that often the data governance people and the cybersecurity people are, unfortunately, the last ones called for many of these things, but they're probably some of the most important people because they're really critical to the success of your project. In fact, data governance, I would argue, is actually almost always more important than the analytics themselves. And that's primarily because of the old theory about garbage in, garbage out, right? If you don't know what the quality of your data is and you don't have a good handle on that, where you can measure it and you can actually improve it, then you're actually not going to get very good results. Your model itself is always going to have some level of inaccuracy in it. And one other thing to keep in mind about data governance, I have been told more than once that utilities are on a journey for data governance, and when they get this certain threshold or milestone, they think they'll have it. But I always like to say that data governance is a journey and not a destination. because data governance is essentially defined not just by the data itself, but by the questions that are being asked of it. And as we continue to ask more and more questions to create more and more analytics insights, the actual threshold of what is good data quality itself will always be moving. And so we'll always be trying to improve the data governance of the system. And it's not actually a place we'll actually end up and be able to check the box and say it's done. Another bit here, and this is unfortunately one of the areas that I think confuses most energy companies, is that the landscape itself for people who do things in this space is very crowded. And they're not yet clear winners. I mean, if we want a car, we know that there are a few domestic suppliers and there are several international suppliers, and you can go find one of those and it's pretty straightforward. But analytics itself, that landscape is constantly changing. There are constantly mergers and acquisitions. There are constantly new companies being formed. I mean, my own company, Google, we wouldn't even exist over 20 something years ago. And so, you can see that the whole space here is just rapidly evolving, and there are lots and lots and lots of players. And so this even adds more to the confusion about what to do. So let's talk about what's happening now. We've kind of set the stage as to what happened in the past and how we got to today. We've talked a lot about what's generally in analytics and what's the parts and pieces and the types of people that are in that space, and also provided a few insights as to how analytics themselves are being used to transform utilities. But let's actually dive deep into a business, ours in this case, to think about how analytics is being used. Now, I'm going to use Google as a proxy for what's going on at utilities, and that may seem a little nutty, but let's consider at Google, most everyone here is an engineer. Utilities are actually the same. We also have a consensus-driven culture, as do utilities, and we focus on reliable, low-cost, sustainable, and equitable infrastructure with dealing with lots and lots of change management. Utilities have the exact same issues. And so while all those things are similar, and we're going to talk through all these things, and like I said, I'll show you what's going on in the energy space here in terms of the innovations and how we manage it at the wholesale level and the bulk power side. But there are a few differences, and I would be remiss if I didn't mention things like we get to wear shorts and t-shirts, and we get a lot of swag, and we use a lot of memes in our presentations, and that's really different than utilities. But for now, we'll stick with the analogy that Google and utilities are kind of on a similar journey in terms of their use of data as it pertains to energy. So first, why Google? I mean, I could have picked any tech company, but other than the fact that I work here, why are we talking about Google when it pertains to energy and analytics and how it's being used here? Well, Google, as you're probably familiar with, has a lot of products with over 1 billion users globally. So with all that infrastructure and all those products, it means we need to be able to scale, but it also means that we use a lot of electricity. Example here, in 2019, we used more electricity than the entire state of Hawaii. That's a lot of energy. And we continue to grow quite a bit. So I'm sure we'll have bigger states here in our analogies coming forward. As I mentioned, our data centers, they have to operate. And reliable electricity is really what allows us to provide our services without interruption. So you can imagine that having a data center go down, like we saw with Facebook not too long ago, where their whole infrastructure itself went dark in the United States, that's really bad. And not only is it really bad, but all of that's fueled by electricity. Without the electricity, without that reliable supply, we can't do what we do. So it's really, really important to us. And as I mentioned, we have very similar goals. Resiliency, meaning the grid itself has to operate as expected and provide at least 5 nines of reliability. Things have to be economic. We may be using a lot of energy, but we don't want to pay a lot for it. I don't think anyone wants to pay a lot for it. And so we want things to be as economic as possible. We want things to be clean. Our customers actually demand it of us. They expect that when they're using a Nest thermostat, or when they're using our products online or our cloud capabilities, they want to know that what they're doing is sustainable. And so that attribute is really important to us. And then, of course, equitable. And when we're trying to get products to billions of customers, equity is really important to us. Now, these are all actually very similar for utilities too. They also have as their primary goal is the resiliency of the system. They're also trying to minimize cost. They also have sustainability goals. And most importantly, their service is kind of a requirement for everyday life. And so equity is also a huge driver for them. So as you can see, our objectives and the utilities objectives actually line up quite well. But as I mentioned, we're really trying to use analytics to drive some of these behaviors and to improve on them. And so one of the ways we do this is actually thinking about how we manage energy at our data centers. Just like how utilities think about improving the health and life of their assets and be able to identify when they're having problems and what to do about them, we do the same thing with our data centers. And so we do all sorts of interesting things, both in terms of the design of the system, as well as the analytics of the system to run and optimize the performance of the assets to actually reduce the amount of energy that we get, that we use. And Google's data centers are, at least in most instances, 2 times more energy efficient than a typical data center anywhere else. So that's how we use energy efficiently, but how do we buy it efficiently? How do we consume it such that it's sustainable? Well, actually, since 2007, Google has been carbon neutral. And since 2017, we've been 100% renewable energy. But as we know, 100% renewable energy on a global basis means that on an annual 1-year basis that we have had at least 100% of energy produced by new to the world renewable energy. It doesn't mean we match it every hour nor in every location, but it means on the global basis, on an annual basis, that we do. And while we've been that way since 2017, that's not quite enough for us. And there's several reasons that we need to actually improve. So the path for 100% renewable isn't just our own. It's also what we see with a whole bunch of other companies too. So Google isn't the only one doing this transformation. We actually see it not just in big tech. We also see it in lots of other industries, from automotive and transportation to healthcare and, gosh, consumer packaged goods. It's really companies across the board are all following suit as not only the costs of these assets come down, and therefore the economic benefits are improved, but also their customers are demanding these sorts of capabilities. And so I think this is a path that's here to stay. But as I mentioned, when we think about the analytics and the forecast of the system relative to what's happening every hour at every data center, we can actually tell that the consumption doesn't match up perfectly for both clean energy or carbon-free energy and what's actually happening at our data centers. And this is just a selection of our data centers, but you can actually see, using this carbon clock for each one of the data centers, roughly how close we actually get to carbon-free. And the greener ones, what you see is higher levels of round-the-clock carbon-free energy. And in the darker ones, you see where we have lots of carbon-based generation, carbon-based energy consumption. And this involves not only for us being able to pull a whole bunch of information from all of our data centers, but also able to turn this into forecasts where we're doing production cost modeling, unit commitment modeling, security constraint unit modeling for assets all over the world and any of the grids where we are. Essentially, it's in building together what sort of things might be of interest to us in terms of the carbon production of that energy. So we're not just forecasting the price, but also forecasting the carbon. This is really important because carbon production isn't necessarily, off-the-shelf data one can go get. So we actually have to munge data from a variety of sources and third parties to create this sort of insight. But creating the insight is one thing, right? It gives us the first set of insights to say, here's what we expect energy consumption and carbon content to look like, not just now, but in forward forecast time periods. Also, what do we do about it? And so let's look at this basically zooming in on one of our data centers and trying to take a look at what actually this looks like, and then we'll talk about the application of analytics on it. So this is the data center itself. If we did nothing in Iowa, and roughly from midnight to midnight, from January 1st through December 31st, you can see that some of the hours have carbon-free energy, but a lot of the hours don't. And so roughly about 30% of the energy is carbon-free. When you add on top of that the production from our renewable energy assets that are local to the data center, meaning within the same roughly wholesale region, we actually jump from 29% carbon-free energy to 78% carbon-free energy. But you can still see there are gaps in there. And a lot of those gaps happen in particular times where the assets aren't producing for a variety of reasons. We don't have enough. And so we just have this kind of mismatch. But we're doing a lot better. And the idea here is, of course, to go from whatever level we have today to 100% carbon-free. And to do that, we have to do a variety of things that involve both technology, procurement, policy, as well as just generally data and analytics. And we think this is important because not only are we trying to improve our own capabilities, but we're trying to actually help others do the same thing. And so we want everyone to actually have a viable path to this. And so that means that a lot of what we do, we need to find ways to open source or help others get to the same point. And so I mentioned one of the things we do is obviously how we buy energy. And actually what we see is that roughly 60 new gigawatts of procurement for renewable energy is we expect just on the corporate buyers. That is an incredible amount of new energy production by 2025. At the same time, all of that's going on, utilities and energy companies themselves make up about another 60 gigawatts. So you're talking about 120 gigawatts in total of new energy production. And this is a considerable transformation going on. At the same time we're doing all that, obviously battery storage itself is becoming far cheaper. It can be used now as a short-term generator replacement for data centers. And we're looking at other technologies, other battery technology, other storage technologies to be able to have a cleaner, longer lasting backup supply rather than just what a battery itself will provide. This also gives us the ability now to have flexible capacity such that we can provide ancillary services or energy or whatnot or capacity reductions for the grid. And this can also help improve not just the grid's resiliency, but the cost for us as well as the cost for the grid itself. This can dramatically improve things for everyone because we're providing these resources back to the grid. And so I've hinted around a lot, but let's now start talking about the analytics. And so one of the things that utilities and Google also do is they're very, very concerned about how to bid in and utilize these resources. Because the resources themselves aren't very predictable, you have to have a good predictive model that isn't just predicting things like what's the weather look like, over some forecast horizon, but also things like, for example, how do I determine how much I should hold back and put into the day-ahead market versus the real time? And what do I do if, for example, some extreme circumstances happening and my assets that are normally available are not available? And so we actually use analytics to do a lot of that forecasting to give us better insights as to how to dispatch those assets and how best to monetize them in the markets and how best to maximize their carbon-free energy output. This is one of the important ways that we use analytics. It's also similar to what a lot of utilities are doing. They're attempting to model and forecast a lot of these assets to attempt to figure out what are they going to do and how should I react on the rest of the system to be able to manage and maximize the value of these assets. We also use machine learning to increase the value of wind, not just by being able to predict when to put it into the market, but also how the market price formation itself is going. So we're actually trying to model, or we are modeling, what are all the other units doing in the transmission and how's the market behaving? Is it constrained? Is it not? What do imports look like? Are these assets on maintenance or whatnot? So this actually helps us understand the price formation and then in turn helps us better decide when should we actually be dispatching them and how should we be dispatching them. And of course, we use machine learning too to do things like visual inspections on those assets to improve asset health and figuring out how we should time and utilize maintenance relative to the assets themselves. These are also similar cases to what utilities do for their own assets when they're thinking about how should I be running this asset, and how should I detect things like defects on the turbine, lightning strikes, bird strikes, whatever. When do I need to know what to maintain and do maintenance on versus what should I keep operating? And so when you start thinking about the combination of these two things, basically how to maintain your assets and the maintenance schedule of them, when compared to things like price forecasting and renewables forecasting, I actually see some nice synergies, because you start to understand that utilities can start to predict when and how and they should best actually maintain their assets so they maximize their value, but also how do they get the best out of those assets when it comes to day ahead versus real time markets. And they're all driven by analytics. And so what we see here is that in our own scenarios is that our typical consumption would be that dotted line that kind of runs left to right here in terms of total consumption. And we're actually able to, as you can see from the blue and red lines, these are just solar projects themselves. But when we add storage to the capability, we're actually able to start to shift that and make that a slightly longer duration. And then if we have some firm capacity from a carbon-free energy resource, storage plus solar, we're actually able to do even more and then bend it down. And so those are the sorts of things you can see that as we keep layering those on, we want to keep making that curve flatter and flatter and flatter, such that we can get to 100% carbon-free energy. And like I said, this is all driven based off of not only using hardware better, but having really analytics to tell us the insights on how to use the hardware better. At the same time, as I mentioned, we're active participants in the markets. We've traditionally bought things like RECs, renewable energy credits, that basically are not time dependent. Basically, they state for this month, we've produced this much energy and this is your REC. But what we're really looking at now are new innovations like time-based energy attribute certificates, or TEECs. These sorts of things actually help us not only better match consumption to renewable energy, but they also allow for better market pricing signals to be sent. And so when we think about those, and we've done this here in the Midwest, when we think about that, that actually allows for cleaner price signals to the market. And it allows developers to see things like, hey, here's where I need to be actually developing and investing, as opposed to these sort of generic RECs that we've got today. And once again, all that's driven by analytics and being able to visualize not just the production, but also the carbon-free energy content that's going on. One last way we're using analytics is in thinking about intelligent load shifting. And so this is a really important concept, because traditionally load or demand for any customer that's attached to the grid is largely based on what they're doing, right? Maybe if they've got a lot of air conditioning, then it rises and falls and cycles as it's hot outside or as it's cold outside, the heating load, whatnot. And that the more extreme the weather up or down, the more the energy consumption is. Customers, up until relatively recently, haven't had the ability really to shift their load. But smart thermostats like Nests, they actually give retail customers the ability now to start to adjust their consumption intelligently. Basically, there's a learning algorithm or algorithms within the Nest thermostat that allows it to determine things like what's the customer's preferred comfort and convenience over the next few hours, and then based on the temperature and the kind of the ability of this building to retain heat, when should I start cooling? And how do I do that in ways that save the customer money? I used to joke when I was in a utility, we used to think about how fast we would update our rates, and I would joke about my Enron past when I would say things like, well, if you think about it, an intelligent asset can update its pricing algorithm basically within seconds when given new data, like a change in price. But utilities themselves, unfortunately, it takes weeks, months, or years to actually change their pricing. And so due to that mismatch between the utilities' very slow cycle to get approval to change their prices versus the intelligent assets, whether customer-owned or utility-owned, their speed at which they can actually change their state, their optimization, means that they're creating a natural arbitrage where the utility loses. And when I think about that, I think about how so much of the infrastructure needs to be converted to a more digital and needs to have better access to data so that those arbitrages are actually in everyone's best interest as opposed to perhaps a one-way street there. But what Google is doing is kind of that on steroids, which is to say, we figured out how to manage and predict not just our workloads, in other words, how much computing we need and where that computing is, but also we've been doing a bunch of experiments and basically running this capability to actually now shift our consumption such that we can maximize the carbon-free energy content of our consumption. Now, this is really important because we're not just shifting it in time, meaning let's just push it out an hour or two, but also we could move it geospatially. We could move it from data center A to data center B. And so this sort of ability to move both temporally and geographically based on our ability to forecast carbon content of the grid, forward pricing, et cetera, means now that we have more control of our infrastructure in ways that allow us to improve the resiliency. So for example, if we think that something is going to, we're estimating that something perhaps might take a data center offline, we can actually move that load out of the data center, so that improves the resiliency of the infrastructure. We can improve the economics, right? By forecasting the prices, we can actually say, it's probably better not to be running at this time at this place. Why not shift it to a place where it's lower cost? We can improve the sustainability too. We can say, yep, this is a good place to run, but and now is a good time to run it, but the carbon content's pretty bad. Why not shift it to someplace where it's better? And so we can actually tackle all of these problems just by using these algorithms. And what it means is that, as I was saying in the beginning, we're not actually doing anything truly new in the sense that there have always been people who are trying to optimize the production of the system, the consumption of energy, et cetera. But they've been using spreadsheets or heck gut intuition before. Now we're actually able to automate that, to feed it machine learning based insights, basically utilize the digital fabric of our infrastructure to improve all these attributes of our system. And utilities are doing the exact same thing. And that's why they're investing in analytics teams. It's why they're investing in data. It's why they're investing so much in digital transformations, because this sort of transformation allows them not just to make a more resilient grid or lower their costs, but heck, to reduce risk, right? And to improve performance and to do things like to hit their own carbon-free energy goals. And so this sort of thing is really, really important because it's really all the carbon-free energy work, all the transformation work, it's really being driven by a digital infrastructure, and really at the heart of it, it's driven by data and analytics. And so while we spend a lot of time talking about Google, the same thing is going on within every utility. They're all trying to figure out how to use data better. They're all trying to figure out how to manage their grids, their supply, their demand in ways that they've never really been able to do. And now that computing is cheap and networking costs are minimal and analytics and data are something that can be developed and deployed more easily, we see a whole lot of transformation going on in this space. And so a final takeaway, lesson 4 is really around the data governance and analytics can be used to enhance everything. I can't tell you how many times I've been asked about, well, what about my HR model that is trying to predict how many employees are going to stay and how many are going to go and how many are retiring. Literally everything that's done today, whether it's done by a human, whether it's done somehow in a spreadsheet or whatever, data governance and analytics can be used to enhance all of it. The only real limitation that we have is our own imagination and perhaps budget every now and again. And so the whole idea here is that where utilities can go in this space is literally to use analytics in the fabric of everything that they do, how they engage consumers, how they run their systems more safely, reliably, and affordably. It's all part and parcel with how we use analytics. And Google's no different. But the key thing is that we're at the beginning stages. Even though there's been a whole lot of transformation, even in the last few years, we're really, really just beginning to peel back the first layer of the onion. And I expect that the things that we'll do over the next 5-10 years are going to be incredible. And I expect to see even more transformation, even broader transformation than what we've already seen today. And so with that, I've concluded my remarks. I'll happily take any questions people may have.
All right. Ending with the bacon man. All right. So there's a couple good questions here on Q&A, so I'll start with those. One is about, does Google offer shifts for its employees for carbon intelligent load shifting? So have the insights that you've discussed regarding shifting data center load, has this affected behavior of people or employees in some way to minimize carbon? So don't just talk about data centers. What about people that work at Google? Anything on that?
Yeah, well, so I used to, if you've seen my bio, I used to run the energy team that did all that work. And I can tell you that the most interesting aspect about energy here is that while our primary mission is around tech and a lot of what we do in that space, the easiest area, the thing that gets employees most excited actually is this area, is energy, is sustainability, is thinking about how to better run and manage these systems. We never have a shortage of folks that say they're interested in this space. While we haven't seen changes in terms of crew scheduling because we have to have data centers, they have to operate, we have dramatically seen improvements in our data centers, both their energy usage or as we measure it in PUE. We've also seen it in terms of the carbon content of our grid and how we manage our own energy consumption. And that we publicize that there's a whole series of white papers that show what we're doing. And so the real transformation we've been able to point to has been really around the operations.
Right. Let me maybe follow up on that. How unique is a company like Google or a company who maybe does, I don't know, computation is a major part of serving doing what its business does. You're able to shift your consumption in space. People think about it in time, but you're able to shift it to data centers around the world. It sounds kind of unique to me. Am I too closed-minded? Am I not open to lots of other companies, or certainly manufacturing? There's only a few facilities in one location versus another, but maybe big companies. I don't know.
Yeah, I mean, I think you raise a really good question, and as the way we've thought about it is that Google, just because our infrastructure is primarily driven based on silicon, is that our infrastructure itself is largely digital to start with, and to some degree, every industry, even manufacturing, whatnot, they're all going through the same transformation to go from analog mechanical systems to more digital ones. Yes, they still may have a machine that's doing some level of work, but it's increasingly networked, it's increasingly digital, and it's increasingly diverse. As we can see from the global supply chain problems that are going on right now, the supply chain stretches across the world. And so what we think of that we can do here on ours is just a preview of what's to come as all the rest of those industries do their same transformation, and that they will have the exact same capabilities. Maybe not because they're doing computing like we are, but they'll have the exact same capabilities to create forecasts, basically to create insights, and ultimately shift consumption or shift development, production, logistics, et cetera, based on a variety of attributes, whether it's the cost of energy, the cost of labor, the availability of parts. Basically, it's just another big analytics problem. It's primarily being driven by the digitalization of the infrastructure. And so I think Google just happens to be on the fast part of the curve, and lots of other people will continue to follow in lots of different industries.
Right. I guess that's a good way to say it. So maybe, yeah, Google, just because of its business model, is able to take advantage of this now and shift things based upon seconds or minutes. But another company might be thinking about shifting things within years or investments, but the same analytics capability might still hold. All right. So in terms of thinking about, I guess, the electricity industry, or maybe energy in general, but electricity, is there anyone would you say is at the forefront of the curve towards moving to what you're talking about? Google, maybe you consider Google a utility as well, just because maybe you own. I don't know how much generation you own versus contract with, but are there any other companies that seem at the forefront of the curve in the United States or anywhere else in the world that you're willing to say?
Yeah, I mean, I think there are several. I think the way to avoid annoying people that I don't mention versus make happy the people that I do mention, I will say that I have been impressed with gladly impressed with some of the things that are going on in the industry. What you're seeing is basically the industry is undergoing a rapid revolution in the space very, very, very quickly. And there are companies that are on that leading edge. I would look for the ones that have tangible investments in it, that talk about it on their annual report. They make it a core part of who they are is transformation. And like I said, there are several energy companies that I think are very advanced in this space, and frankly, I think they're going to do things that are going to knock people's socks off.
Excellent. Well, here's a good question for us here at a university. If you're somebody at a university studying engineering and trying to be smart and maybe wants to work in the energy system or the utility, what kind of skills do you think you'd prioritize in terms? Yeah, maybe engineering, classic skills, physical modeling, and of course this programming. Is it a balance of all three, many things, or how do they figure out what they're learning while they're here?
Yeah. Well, I mean, first and foremost, a good understanding of how the energy system works is very important. It doesn't matter whether you're going to end up in finance or trading or doing power system design or whatever, right? You all have to understand the basics. And so to me, anything that helps cover the basics is going to be super helpful. That being said, having capabilities to use analytics beyond spreadsheets, having capabilities in analytics I think is kind of like the next most important job capabilities that you need to have. Obviously, things like communication and having executive presence and being able to talk to different audiences and write well and so on, those are given requirements. But most of what I don't see yet are people who have also spent a commensurate amount of time understanding machine learning and those techniques, artificial intelligence, being able to deal with data. They poke around with MATLAB or some simulation software. That's great, but you really need to take a course or two or three in the space to really be able to do a lot with these skills. And so I would strongly suggest adding to the curriculum, to their study curriculum, something understanding the use of these sorts of analytics techniques, because they're almost immediately going to get asked to use them once they get to any energy company.
Right. I think that is a big difference between when I was in school. It's like maybe coming out now as an engineer, you, in some sense, might be expected to have a little bit more fundamental programming skills. Yeah, and there is a person here at UT who teaches a class called Too Big to Excel, which is how to handle things outside the spreadsheet, right? So it's a good title for the class. Here's another good question. This one's about Texas, but could be other areas a little bit. In terms of Google moving forward toward decarbonization for itself, and you talk about making open source products as well to help other companies. Is there energy producers that Google works with to try to help decarbonize the electricity supply in any areas in Texas or then ERCOT, or how does Google choose where to put server farms or infrastructure, and does it matter who's in that same area? Does it matter what the rules and regulations are and the aspirations of that area are?
Yeah, it matters quite a bit. So for Google, and really I'll answer this for the industry more so than for Google per se. Energy is the single largest driver of cost for variable costs for any data center. And so other than things like tax and legal issues and that sort of treasury issues, kind of the laws that say maybe my data has to remain local to some geography. Other than that, the major driver is going to be on energy. Utilities are also the single longest lead time item. So in other words, we can stand up a building really quickly. We can put in a whole bunch of computers and networking equipment and whatnot, but it takes a long time to build the utility infrastructure to actually get to the data center. And so with that, those decisions about not just where to put it, but things like, is there a ready supply of low-cost energy there because it's a high driver of cost? Or how long is it going to take me to get an interconnection at this voltage level? Those will drive a lot of decisions. And now, if you can imagine, because Google in this instance happens to run one of the world's largest fiber networks, putting a data center in, say, Dallas versus one in El Paso versus one in Houston, from a speed of light perspective, doesn't make much difference. But the energy costs and the reliability and resiliency of the grid sure do vary in each of those spots. And so once again, if it's the one thing we've got to have to make a data center run, and it's our single largest driver of cost, and it's the single longest lead time item, it means that most of the conversation is going to be around the grid, the availability of those resources, the cost of those resources, the cleanliness of those resources. And that is, other than, like I said, the tax, treasury, and legal issues, that's the primary driver of deciding where a data center goes.
Are there any partnerships that Google pursues in terms of energy, purchasing energy, partnerships with energy companies, or do you just kind of put out bids for who's going to sell you low carbon energy at the lowest cost and go from there?
Yeah, when I first got here, we did the world's largest reverse auction for renewable energy in markets all over the world. Nearly killed the team. We decided that what we really wanted to do, rather than kill everyone, was to figure out a smarter way to procure energy. And that actually means partnerships, key strategic partnerships in certain geographies. And so, yeah, Google, Microsoft, Amazon, Facebook, they all do the same, which is they really prefer to work with a partner who's willing to be innovative and think outside the box. Someone who's willing to perhaps help with some of the problems around data and analytics, or being able to cut times on grid integration. I think all high-tech companies would work hand in glove with them, and I know we do too, which is to say we're less and less more like, here's my broad RFP, just respond to it and I'll pick one, to more like, how do I partner with the right energy companies in the right places to do the right thing?
Right. Okay. Here's maybe a good one, a little bit different than what you discussed. How does Google, I'd say the question is, how does Google value, but maybe it could be, how does Google think in general about carbon capture, either from point sources or direct air capture or anything in terms of carbon-free energy generation? Is that too far beyond what Google's thinking now, or is Google thinking about something about that now? Anything to say there from
Yeah, I mean, first off, I'll remind, I work in a place called X, the Moonshot factory. So clearly, Google's ideas around taking bets on things that are innovative, new, out of the box, perhaps haven't quite matured yet. Google has put a lot of time and effort behind those sorts of initiatives, and I would say we are absolutely looking at those spaces. We don't think there's a one-size-fits-all solution in every grid everywhere, and therefore we think we have to make a variety of bets on both not only readily available technology now, but nascent technology, stuff that's coming, it's not quite here yet, and we need to make a lot of them because we know not all of them are going to pay off. It means we have to also build a lot of the infrastructure, the digital infrastructure, the analytics infrastructure, the data governance infrastructure that's necessary to carry this off, because frankly, if we don't, we'll be waiting around for someone else to do it and it won't be done. Everybody has their priorities. Ours is to see this transformation happen. And so, yes, we look at everything on direct air capture, we look at geothermal, a whole variety of things. And, I don't think we have an answer yet as to what's the right one, but we're going to make a lot of different bets to try and figure out the right path forward.
Right. Good. Maybe we'll got one more here. These are good questions. Thank you very much, everyone. Maybe tackle this one more here. So maybe goes along with Google open sourcing kind of things. What startups are you aware of that are enabling digital transformation for utilities with off-the-shelf products? There's just a person here mentioning one. I'm not familiar with TagUp in Boston, to develop a platform to support condition-based maintenance off the shelf. So, maybe you could say how the things you're working on, you're modeling the grids around the world, I guess you're saying, right, for dispatch and this kind of thing. We can imagine, obviously we have Google Maps as an open source, software, if you will, that people use a lot. I'm wondering if you can imagine that we'll all be able to look at Google's, online grid commitment model. But aside from that, what other kinds of things do you think are good for off the shelf that companies are going to be able to use?
Yeah, well, if I may indulge, I mean, this is an area I should plug for our own area. I mean, this is what we're working on, right? We're working
Yeah,
on transforming the grid itself, and that means transforming not just how we govern the data or make the data available and kind of unlock it from all those silos, but also how do we better simulate? How do we apply machine learning to that to make it go not just a lot faster, but take all the human messiness and elements out of it that slow it down so much? How do we enable orchestration of grid assets? How do we enable a new frame for optimization to enable things like sustainability, not just resiliency and cost, but also sustainability and equity? And so, yeah, we're very active in that space, and there are a variety of companies in this space too. The analytics chart I showed earlier, where there was a myriad of companies, the icons are getting smaller and smaller because there's so many in there.
yeah,
Um, I could say the same about the energy space right now. As a matter of fact, it's probably at its biggest scale I've ever seen in my career in terms of people investing in and starting up new technology companies in the space to try and do something new and exciting. You could almost throw a rock and hit 10 of them. And so there are a ton of exciting things going on in the space. If you have an energy background and you like tech, this is probably your moment in the sun.
excellent. Well, maybe that sounds like a good place to end with the moment in the sun. So, thank you again, Raiford Smith with X and the Moonshot Factory now at Google, and we'll keep tabs on you. Thanks for a very interesting